Okay, so let's set up our microbit and our conductivity probe. The first thing we have here are 4 wires, and each wire has one crocodile clip on top and bottom. Next, we have a breadboard, and on this breadboard we have a 56 ohm resistor. Of course, we have our microbit here. And to power our microbit, we have a battery pack with 2 AAA batteries. And finally, we have our conductivity probe. So this consists of 2 copper wires in a plastic sheet that was actually 3D printed in the physics lab. So let's go about assembling this. The first thing we need to do is apply power to our microbit. To do that, we can place the port of our battery pack into our microbit gently, and when we have power we will see this lovely little monster face pop up on our microbit. The next thing we're going to do is build our circuit. So we have a wire here with crocodile clips. The colour doesn't matter, all the wires will do the same job. So we're attaching one crocodile clip to one end of our copper wires, and the other crocodile clip of this wire goes onto our resistor. And I'm making sure it's just firmly in place there. Next, I'm going to take another wire, and using crocodile clips I'm going to secure it to the other side of our resistor, just like so. The end of this wire is going to be attached to the ground pin of our microbit, so that's the last pin you see here. And I'm just making sure all of these pins are aligned and they're nice and secure. Next, I'm taking my green wire here, and this wire is particularly special because it's going to be connected again to the same side of the resistor as our yellow wire. And this one is going to go to P1. And the purpose of this wire is to measure the current that's actually flowing through. So this is what will give us our voltage level value later on. And finally, to complete our circuit, I'm taking my red wire. One end is going onto the other copper wire of our conductivity probe, and we're completing our circuit by attaching this to P0 on our microbit. So now we have built our conductivity probe and we can now complete our experiment. So what's going to happen next? Well, you have created a series of solutions of sodium chloride ranging from 0 grams per litre all the way to 10 grams per litre, and we can test the conductivity of these. To do so, what we can do is take the solution of interest, about 50 ml in a beaker is plenty. This is just our 2 grams per litre of sodium chloride here as an example. We can take our probe and just submerge it and hold it in place for a few seconds. When we're ready, we can press the button A on our microbit, and a voltage level reading will appear on the microbit interface. And this is the value that you record in your results table under voltage level. So the microbit doesn't actually record conductivity as your traditional or your commercial conductivity probe does. It measures voltage levels instead. So when we want to convert from voltage levels to the units of conductivity, which today is microsiemen, we will use a factor to multiply by. So every value you get for your voltage level, you will multiply that by 150 to give you your conductivity value in microsiemens. So that's our setup. Give it a go and see how you get on.